After setting up the third sensor, we will set the fourth sensor. Select Cylinder, Automatic. Click OK. After setting up the sensors, we also need to configure the actuators for the blocking cylinders. If we play now, they will fall because we haven't set position limits yet. In the electrical under position control, set blocking cylinder 1, blocking cylinder 2, and the pushing cylinder to control their positions, giving them double the speed while leaving the target values unset for now. The second blocking cylinder is set up in the same way, and the top cylinder will have the same settings for position control. In the electrical under the drop-down menu, find the transport surface to set up the conveyor's actuator. Specifying the vector direction to the left. The second conveyor will have the same direction, but we will not set the speed yet. We'll unify that in the signal settings. Click OK. We still need to set up an object transformation as the material reaches this position for laser marking. To show the difference between marked and unmarked items, we will configure the object transformation. Click on the transformation sensor, which is the fourth sensor, and set the transformed object to the processed material. Change the name. Click OK. Now, the basic physics settings for joints, sensors, and actuators are complete. Next, we need to configure the signals. Click Electrical, Symbol Table, and Signal Adapter. We'll use the same method to set up two types of signals. One is the input signal, which controls the movement of the model, and the other is the feedback signal. Let's start by setting up the input signals. The first step is to set up the conveyor belt. We need to ensure that one signal controls both conveyor belts. Otherwise, the material flow will be problematic. When the signal for the conveyor belt comes in, set the speed to 200. If there's no signal, it should be 0. Here we use a formula for conversion. Similarly, configure conveyor belt 2. control both conveyor belts using the same signal, effectively treating them as one continuous conveyor. Note that the speed here must be consistent with the previous conveyor belt. Next, set up the signal inputs for the 3 actuators. Add an input signal for blocking cylinder 1. And copy the entire configuration. When the signal for the blocking cylinder comes in, it should execute a position of 30. Use the same method to configure blocking cylinder 2 and the pushing cylinder. Note that the parameter here is the position. Copy the entire signal configuration. Then set up the pushing cylinder. When the signal for the top cylinder comes in, the actuator should execute 50 mm. The input signal setup is now complete. Click OK. You can create a symbol table here, but it's not mandatory and won't have any impact. Next, we'll set up the output signals. Click on the collision sensor and add it as an output signal. We need to configure it as an output signal. The data type above is signal, and the data type below is also signal, so these 2 signals can be set to be equal without any formula conversion. Similarly, set sensors 2 and 3 as output signals. The output signals are completed. Click OK. The basic physics settings for the laser marking unit, including droids, sensors, actuators, and signal configurations, are now finished. Today, we learned how to use the MCD module to set up a laser marking unit. This not only enhanced our technical operation skills, but also deepened our understanding of applying theoretical knowledge. Finally, please complete the following exercises. This concludes today's lesson. In the next class, we will continue to learn how to program in the PLC.